All right, so inverse functions. Let's chat about them. So inverse functions are basically backwards functions. You take a function, you flip it around, and you make it backwards. We're going to do two things today. We are going to verify that functions are inverses of each other, and we are going to find inverses. So, to verify that a function is an inverse of another function, we take and find f of g of x and g of f of x. F of g of x has to equal x, and g of f of x has to equal x. So that's what we did in 2.6c, that composition of functions. I do have another pencil. Vivian, did you get your pencil working?
No.
Okay, give one to Vivian too.
No, I haven't.
You have one? Okay, don't give one to Vivian. All right, so we are going to start by finding f of g of x, which means that we are going to take g of x and plug it in right here for x. So it'll be 3 times x minus 2 all over 3 plus 2. So I took this guy and I plugged it in for x.
So there's not going to be very many people in this next. No, there's like 90 people. Oh well, that's pretty small class.
Okay, then we need to simplify that out. The 3's cancel. So we just have x minus 2 plus 2. That's really impressive of that one in the trash can. Oh, that should be x minus 2 plus 2. Sorry, I was focused on the pen not working. That's x minus 2 plus 2. Negative 2 plus 2 is 0, so this is just x. So we have verified it one direction, that f of g of x equals x.
Oh, wait, do you not?
What's that?
Do you not distribute it to all of them?
So distribute the 3?
Yeah.
If I were to distribute that 3 to the x and the 3 to the negative 2, then I could just divide by 3.
And I'd get the same thing.
And then you get the same thing, yeah. The 3's would just cancel out later. Okay. Then, in order to verify that it's an inverse, this has to work. F of g of x has to equal x, and g of f of x also has to equal x. So f of g of x has to equal x, and g of f of x has to equal x. So g of f of x would be us taking f of x, so 3x plus 2, plugging it in right here for x. So that's going to be 3x plus 2 minus 2 all over 3. Okay, I really didn't need those parentheses when I plugged it in because there's nothing to be distributed. So the plus 2 minus 2 can just cancel out. And so then I have 3x over 3. And then 3x divided by 3 is just x. So what we have done is we have verified that these are functions. And so at the end of this, we could say, yep, they are functions. And there's going to be a little checkbox, and you're going to check, is it a function? And the answer is yes. If I were to plug these in and not get x, so if it doesn't simplify down to x, then it is not a function. Okay. Any questions about either of those? Hey. Other thing that we are going to do is we are going to find inverses. Let me zoom out so we can go through these steps together. So, To find the inverse of a function, we're going to take the f of x equals and we're going to replace it with a y. So we're just switching out f of x for y. That's pretty interchangeable. Then we literally switch our x and y, and then solve for y. So we switch x and y, and then solve for y again. Get y by itself again. If the equation does not define y as a function of x, then the function does not have an inverse, and the procedure ends. If it does, then it does have an inverse function. If f has an inverse function, then we change it back, but we don't change it back to f of x, we change it back to f inverse of x. So f to the -1 of x, that means f inverse of x. And then we can verify doing that, verify it doing the same thing that we did on the last problem. We're not going to verify them because we're doing them so we're just going to do them correctly. So it's basically 3 steps. It's basically 2 steps, and then a step at the beginning and the end. So step 1 is to replace f of x equals with y equals. So we're going to switch this out. Instead of f of x equals, we're going to write y equals. Okay. Then step 2 is to switch x and y. So we are literally switching where the y is with where the x is. So we're going to have x equals 7y minus 5. Everything else stays the same. Just switch the x and the y. Okay, then we solve for y. So this is step 3, is to solve for y. So we're going to add 5 to both sides. We'll have x plus 5 equals 7. Y. Sorry. And then we'll divide both sides by 7 to get y by itself. So divide by 7, divide by 7. Those cancel out. Okay, so then we have y equals x plus 5 over 7. To finish us out, we're going to write our answer. We're going to switch back that y, but instead of switching it back to f of x, it's now f inverse of x. So f inverse of x equals x plus 5 all over 7. So basically, the inverse has to be both the opposite operations and the opposite order. So we multiplied by 7 and then subtracted 5. And this one we add 5 and then divide by 7. So it's going to end up being the opposite operations in the opposite order. All opposites all the time. Okay, questions on that one? Okay, 2 more. We've got y equals x cubed plus 1. All I'm doing is switching x and y. Or I'm switching f of x for y. Now I'm going to switch x and y. So it's going to be x equals y cubed plus 1. Hey, Jayla, this is for you. I realize you can go now. I was going to have everyone else wait until after notes, but you can go now. What? It's for your counselor? Okay. Then we need to solve for y. So I need to subtract 1 from both sides. I'll have x minus 1 equals y cubed. And then I went ahead and put that in parentheses. Because in order to get that y cubed, I need to take the cube root of both sides. So I'll take the cube root and the cube root. That cube root and cube will cancel out. So it'll end up being y equals cube root of x minus 1. And at that point, we can also switch it back for f inverse of x equals cube root of x minus 1. Yes, it's the cube root, so that's a little 3 by the root symbol. So that makes it a cube root instead of a square root. Okay. So again, opposite operations in the opposite order. So instead of cubing and then adding, we are subtracting and then cube rooting. Last one. Start by plugging in y equals 5 over x plus 4. We're going to switch x and y. X equals 5 over y plus 4. We can subtract 4 from both sides. We'll have x minus 4 equals 5 over y. And there's like 7 different ways we could do this. I think the simplest way to do it and the simplest way to think about it is multiplying both sides by y to get it out of the bottom of our fraction. And then dividing both sides. So then we would have y times x minus 4 equals 5. And then dividing both sides by x minus 4. But then y would be in the denominator, so you would divide by 5 and then have to flip the fraction. Yeah. So then these cancel. We would get y equals 5 over x minus 4. Oh, I'm off the page. Oh my gosh. I'm not doing well today. And then we can switch that out to be f inverse of x equals 5 over x minus 4. So Lilia asked, could we not just divide by 5 here? You could divide by 5, but then y would be in the bottom of the fraction, so you would have to flip both sides. You would end up with the same thing, though. Okay. In a super anticlimactic fashion,